During the course of the following lessons, we will be applying a lot of the concepts that we have already discussed during this year. For today's topic, we're going to talk about the NXT robot. So what are the LEGO Mindstorms robots, or else NXT robots? So basically, this robot is a robot that you can build using normal LEGO blocks. And apart from building the robot, we can make the robot do various actions by programming the robot. In fact, if we were going to do these lessons in class, we could connect the robot to the computer with a USB cable, and we could program the robot using a special programming language which would enable us to make the robot do certain things. So the robot, for example, uses motors for movement. Notice that the robot has two wheels. Each wheel is attached to a motor, and the motor basically turns the wheels. So you can program the robot to turn the wheels so that it can move forward, for example, it can move backward, it can turn right, it can turn left, and using these types of commands, it can perform various actions. Apart from the motors, the robot also has what we call sensors. And sensors basically are devices that can detect information from the environment around the robot. It has sensors that react to light, so they can detect if there is light or there is dark. There are sensors that can react to sound, so if there is, for example, a loud sound, they can detect that sound. There is a sensor that can detect touch. When you press or touch the sensor, it will detect that press. And then there are other sensors. So basically, when we are talking about sensors, we are talking about types of input devices. So the sensors basically give an input to the robot. Then the second part is the process. This is performed by the NXT brick, which is the mind of the robot, so to speak. When we create a program using the programming language, this will be stored in the brick, and the brick will be connected to the various sensors and to the motors, and it will control everything. Finally, we have the output. The output is basically the motors. The process or the brick will give instructions to the motors to move depending on the various inputs and how the program works. So let's start exploring the various components of the robot. So we have the brick, the various sensors and the motors. This is the touch sensor, which we have mentioned that when you press the touch sensor, it will detect that you have been pressing it and give the instruction to the brick. The sound sensor can detect sound. The light sensor can detect dark environments or bright environments. The ultrasonic sensor can detect distance, so it can calculate the distance between a wall, for example, and the ultrasonic sensor. The motors are those that make the robot move around. So, as we said, the NX3 brick is like the mind of the robot. All the sensors and motors are connected to the NXT brick. The NXT brick can be programmed to process inputs from sensors and activate the motors as output. The NXT brick can also output sounds through a speaker, so it has a built-in speaker that produces an output as well as a screen. It has a screen where it can also produce an output as well. So it can output on its own the brick sound, and it can also output visuals on the screen. The NXT brick can be connected to the computer via a USB to be programmed using the LEGO Mindstorms software. This is the software that we would have used if we were doing these lessons in class. However, since we are at home, we are going to use a different software. In fact, we are going to be using Open Roberta Lab, which is an online program which we can use to simulate the NXT kit. What you are seeing right now is Open Roberta Lab. You can access this website by going to lab.open-roberta.org. And basically how this works is on the left of the screen you can program your robot using what we call iconic programming. So you can use different blocks to basically control your robot. We're going to go into further details about this later on. On the right of the screen you have a simulation. You open the simulation screen by pressing the sim button, and you can then see the simulation, which includes the robot, which you can move around using the mouse, okay? And the robot is equipped with all the sensors and the motors like a normal NXT kit. Notice that the environment has different objects in it. For example, it has a boundary wall, which is this yellow and black striped border at the edge of the simulation, and then it has different patterns like this bold black line, which you can use as part of the program, these colored boxes, and as well as an obstacle box which you can also move around on the screen. Okay, so basically the robot can react to these objects in the environment using the various sensors. And then on the left of the screen we can use the blocks to program the robot. For example, I can use an action to make the robot drive forward. I can use an action to check the distance using the ultrasonic sensor between the wall and the robot, and other types of actions that enable the robot to do whatever we want. Let us now start looking at the various components of the robot, including the motors as well as the sensors. Then we have the motors. These are called servo motors because you can control the rotation of the motor. Each motor has a built-in rotation sensor and lets you control your robot movements precisely. The rotation sensor measures motor rotations in the degrees or full rotations. So basically you can program the robot to rotate the motor a certain number of degrees or a certain number of rotations. One rotation is equal to 360 degrees, okay, a whole rotation. So if you set a motor to turn 180 degrees, its output shaft will make half a turn. 180 degrees is half 360 degrees. And as we already said, the motors are output devices. Let's look at the Open Roberta software once again. I would like to show you how to use the motors in the program. Notice that the robot on the screen has two wheels which are connected to the motors. Basically, to make the robot move, we can click on an action and we can decide to make, for example, the robot drive forward at a particular speed. We can specify the speed. I'm going to give it a speed of 100 and a distance of 150 centimeters. When I press the play button down here, the robot will perform the action. So the robot has moved at a speed of 100 and at a distance of 150 centimeters. And it is using the motors to move. I can add further actions. I can make the robot turn around, for example. So I click turn right at a speed of 30 and at a degree of 90 degrees. So if I reset the position of the robot, I can press play again and see the action happening on the screen. So notice the robot has moved forward for 150 centimeters and then turned 90 degrees after 150 centimeters. Once again, remember, at this moment we are using the motors. Then we have the touch sensor. Notice that the touch sensor is like a button that gives your robot a sense of touch. When you press that button, or if that button, for example, hits another object, or if that button hits a wall, it will detect the touch. So the touch sensor detects when it is being pressed by something and when it is released again. Example, when the touch sensor is pressed, you can make your robot perform an action such as move or make a sound. Remember that when we are talking of sensors, these are going to give an input to the NXT brick, and depending on that input, the robot will perform a particular action. Okay, so we could be talking about a robot that hits a wall, for example, and if it detects that it hits a wall, it needs to reverse, for example, and move back. Let us now look at the touch sensor in the simulation. The touch sensor in the simulated robot is basically located in front of the robot. It is this bar in front of the robot. Basically what happens with the touch sensor is when the robot presses against an object, the touch sensor will turn red. For example, if I grab this object here and move it towards the robot, notice the touch sensor turns red. Also, if I move the robot towards the wall, as soon as it touches the wall, the touch sensor turns red. That indicates that the touch sensor is being pressed. So we can now program our robot to perform a particular action. For example, we can make the robot move forward, and if it hits an object, we can make the robot reverse and turn back. So to perform this action, I'm going to open the more advanced part of the blocks by clicking on the 2 button here, and I can start by first introducing a loop, because I want the robot to keep on moving forward until something happens. So I'm going to repeat until the touch sensor is being pressed. If I go into the logic, I can introduce this block here, which connects to this repeat until block, and I can introduce the sensor now. So I'm going to click on sensors, I select touch sensor, and I put it in this part of the block. So my robot is going to repeat the particular action that we're going to place here, which is the driving action. Is going to keep on driving until the touch sensor connected to port 1 is pressed. So if I go to logic, I can introduce a true here, a true block. That means that when the touch sensor is pressed is true. So yes, if the touch sensor is being pressed, perform the action which is into the repeat until block. And the action is going to be to drive forward. So I'm going to place this block inside the repeat until block. So the robot will drive forward at a speed of 30 until the touch sensor is pressed. When the touch sensor is pressed, this repeat block will end. So anything I add after the repeat block will be performed. So I want my robot to drive. In this case, I want it to turn right at a speed of 30 and at 180 degrees, because I want it to look in the other direction. Let us now test this program by clicking the play button. The simulation has started. Notice that the robot is now moving forward, so we are in this part of the program. So drive forward at a speed of 30. Now, as soon as the robot hits an object, in this case the wall, the sensor will light up and the robot will turn. Notice the robot has turned, but since it was very close to the wall, it could not turn fully. So I can modify my program to make the robot move a bit back before turning. So I can go to drive forward, and I'm going to change this to drive backwards at a speed of 30 and a distance of 30 centimeters. So now the robot, as soon as it touches the wall, it will basically drive backwards and then turn 180 degrees. I'm going to reset the position of the robot, start the robot from here to test it and press play. Let's see what happens. The sensor is lit, the robot moves back 30 centimeters and it performs a 180 degree rotation. And that is how the touch sensor works. Then we have the sound sensor. The sound sensor can measure sound pressure levels. Okay, so it can detect if a sound is loud or if a sound is soft. It enables the robot to respond to sound. Again, this is an input device, so it can detect the sound and the robot will perform an action depending on if the sound is loud, for example, or not. Example, when you clap, you can make the robot perform a particular action. The sound sensor should be available on the simulator, but for some reason it is not working for me. I am still going to show you how you can use the sound sensor. For example, we can go into the advanced settings and we can choose a control. I'm going to insert a loop, which is a repeat until loop, because I would like my robot to keep driving forward until it hears a loud sound. For example, if I clap, I would like my robot to drive backwards instead of forward. So what I'm going to do is repeat until, and in the repeat until block I'm going to add a piece of logic here, which is this block here. Notice that the blocks have a color, and these guide you where you can connect them with the other blocks. I'm going to find the sensor, the sound sensor, and I'm going to put the sound sensor here. So repeat until the sound of the sound sensor is equal to, actually I'm going to change this to is greater than, and then I'm going to insert a mathematical value here, greater than 10. So repeat until the sound, the value of the sound, the power of the sound is greater than 10. In the loop, I'm going to add an action to drive. So I'm going to drive forward. Okay, if the sound is less than 10, I'm going to drive forward with a speed of 100. If the sound is greater than 10, the loop will end and I'm going to drive backwards. That should be how the program works, but for some reason I cannot get the sound sensor to work on my system. Maybe you can try it on yours, but here it is not working. I'm going to press play. Notice that the robot is moving forward. Technically, when I clap, it should hear my clap and it should start moving backwards instead of forward, and that basically is how the sound sensor works. The light sensor is one of the two sensors that basically give vision to the robot. Okay, the robot cannot see like we see the world, but it has two types of sensors that it uses to be able to see its environment. Okay, in this case it will able to detect light or dark. So it will be able to tell, for example, if a room is very well lit up or if a room is dark. The light sensor enables your robot to distinguish between light and dark. It can read the light intensity in a room and measure the light intensity of colored surfaces. For example, you can use the light sensor to make a burglar alarm. Okay, you can make a robot to act as an alarm. So when there is an intruder, who turns on the light in the room, the robot can react to defend your property. So for example, if the light is on at night, it might sound an alarm. Okay, remember that the brick has a speaker in it and it can produce sound. So it can, based on the input of the light sensor, if the light sensor detects light, it will sound an alarm, for example. You can also use the light sensor to make the robot follow a black line, for example. So if you place the light sensor on a black line, okay, the light sensor will detect low light because the black line will reflect a little light, and basically it will keep on looking for the black line, and the robot can follow that black line based on the input of the light sensor. And basically the output will be produced by the motors to make the robot move. And again, the light sensor is an input device. So we are back into the simulator, and now we're going to try to use the light sensor. So first of all, I'm going to explain how the light sensor works. Notice that the robot has a circle on it, a white circle at the moment, and when I move this circle on a different colored surface, for example this black line, the circle changes color, okay? That is the light sensor detecting the light beneath it. And when you are over a black line, the light will be very, very low. When you are on a light area, like this white patch here, the light sensor will detect light. So it will be white. So the lighter the background, the higher the value that the light sensor will return. The light sensor will return a value between a 0 and 100. Okay, usually when you are on a black line, the value will be 0, and when you are on a white surface, the value will be 100. Okay, then there are in-betweens. Okay, what I'm going to do is try to program my robot to move around this environment, but I don't want my robot to cross the black line. So let's start with a loop. I'm going to click on the control and look for a loop, and I want my loop to repeat indefinitely. That means that my loop will never stop looping. The first thing I'm going to do is make my robot move around, so I'm going to add an action to drive, and I want my robot to drive forward at a speed of 120. So that will make my robot move forward. Now I want my robot to check if there is the dark line, and for this I'm going to introduce a decision. So I'm going to decision, so I'm going to choose the if condition here. So I'm going to add some logic as well with the if condition. So if the light sensor returns a value that is less than, and I'm going to add a value of 20 here. This takes a bit of trial and error to find out the value that works best. I want now my robot to reverse and turn, so that when the robot is approaching the line, it will reverse and turn and continue moving. So I'm going to choose the drive instead of forward backward at a distance of 20 centimeters should be okay, and again drive turn right at an angle of 90 degrees. Let's try the simulation now. So the robot is moving forward, it detects the line, it goes backwards, it turns, and it continues on moving. And again, it detects the line, it turns, and continues on moving. When you are using any of the sensors in the simulator, you can open the sensor data view here, and this will show you what the sensors are detecting. In our case, we are looking at the light sensor here. Notice it is 100% when the robot is on a white background. When the robot hits the black background, the percentage will go down well below 20%. and that basically is how the light sensor works. Then we have the ultrasonic sensor. This is again one of the input devices that gives vision to the robot. This ultrasonic sensor enables your robot to detect objects by measuring the distance from the object in front of it. So basically, this ultrasonic sensor, if you place an object in front of it, it will measure the distance between the sensor and the object. So if, for example, this sensor is mounted on the robot and the robot is approaching a wall and the distance between the robot and the wall is, for example, 20 centimeters, the robot will turn back so it doesn't hit the wall. That's an example of how you could use the ultrasonic sensor. So it can help the robot to avoid obstacles, sense and measure distance, and detect movement. The ultrasonic sensor uses the same scientific principle as bats. It measures distance by calculating the time it takes for a sound wave to hit an object and return, just like an echo. So basically what the ultrasonic sensor does is it sends a sound, which you do not hear because it's ultrasonic. The sound hits the object in front of it and then it is reflected back into the sensor, and using that principle of an echo, it can detect how long it takes for that sound to come back when it hits the object, and it can measure the distance using that principle. Again, the ultrasonic sensor is an input device. So back to the simulator, now we're going to use the ultrasonic sensor. I'm going to basically keep using the same program that we used for the light sensor, but I'm going to do a slight modification to it. So what I'm going to do is modify the code that I already have. Instead of using the light sensor, I'm going to use the ultrasonic sensor. In this case, I want my robot to keep moving around this whole environment, but I don't want my robot to get stuck against a wall. So as soon as the robot is approaching a wall, I want the ultrasonic sensor to detect the distance between the robot and the wall, and as soon as the distance is less than, say, 20 centimeters, I want my robot to turn so it doesn't hit the wall. Notice how the ultrasonic sensor works. In front of the robot I have these lines which are being emitted from the robot. These lines represent the ultrasonic sensor. Okay, let's look at the program now. I'm going to remove this part here where we are using the light sensor, and instead I'm going to introduce the ultrasonic sensor. Okay, so now my program works like this. As soon as it starts, there is a loop which repeats indefinitely, so the loop never ends. Then my robot will start driving forward at a speed of 1 to 0. Now, I have a condition. If the distance of the ultrasonic sensor is less than 20, and when we're referring to 20, this means 20 centimeters. So if the ultrasonic sensor is detecting a distance of less than 20 centimeters between the robot and the object in front of the robot, I want my robot to drive backwards for a distance of 20 centimeters, and I want my robot to turn right 90 degrees. So let us now test the program. I'm going to press play. The robot has started moving, it's approaching the wall, and notice now that the robot is going backwards and turning because the ultrasonic sensor has detected a wall. Again, every time the ultrasonic sensor detects an object in front of it, in front of the robot will go back and turn. Even if I've used this box as an example, this box is also an object. I can place it in front of the robot. Notice what happens. The robot again detects the object in front of it. So using this method, the robot will not hit the wall. Again, we are using the ultrasonic sensor. The NXT brick has different ports, and basically the sensors and the motors connect to these different ports using special cables that are provided in the kit. The same principle applies in the simulator. So the sensors are connected to different ports and the motors are connected as well to different ports. In fact, notice, for example, when you are programming and using a sensor, in this case, for example, the ultrasonic sensor is connected to port number 4. So if you would like to change these ports or else check to which ports the various sensors are connected, you can do this by clicking on the robot configuration button up here, and from here you can see each sensor to which port it is connected and with the motors to which port as well they are connected. Basically, you do not need to move these around, but you can just use this as a reference while you are programming your robot. And that basically concludes our introduction about the NXT kit and the simulation environment which we will be using to program our robot.